Hey everyone, I'm Priya Ananthasankar. I'm a principal software engineer at Microsoft. Today I'm going to talk about how we are going to do runtime package layering and how that breaks the bloat cycle of your container. This is mostly a talk on Nix packages and containers and from a cloud infrastructure engineer's point of view. I don't claim to be a Nix expert, I'm just learning. Yeah, so let's get to it. Yeah, the views and opinions provided here are my own. They do not reflect those of my employer. Okay, so I want to talk about the parable of the managed console. And this is, if you're a cloud engineer or cloud operator, you have some environments that you manage. And I'm not talking about environments that you give customers to manage. I'm talking about environments that you manage your platform. And typically, you're building a managed console for your cloud platform and something like a dev environment that you want to give everybody. And let's say you have a Docker container or a container system there where you put all your tools, and you start with 2 tools. I'm just going to give bash and some CLI, right? And then you ship it, customers love it, it's fast, the image is about 400 megs, and users love it, right? And then your requests start coming in. Someone wants 3 versions of Python, and then there's like a whole bunch of DevOps tools that people want, and then soon, and Helm and Terraform and whatnot, right? And then you add them because that's the right thing to do. You distribute it. The image is now 4 gigs. Your build time grows, that's fine. Your CI time is fine, but then you're starting to accumulate these managed console tool sets that you want to give people. And I totally agree with Kelsey's previous talk where he said that people just want tools. They're not looking deeply into package manager or packaging. I think that's true in some ways where people are like, give me an environment. I just want these things in my environment. Just spin one up for me, right? And so far we have dev containers as a solution. And I just want to tease that, is it sustainable, right? When you keep bloating it this way. So, and you have a Docker container with all the tools, and then you do one Docker build and all tools upgrade, right? So there's package 1.12, 1.13, let's say there's like a DevOps package. There's two sets of partners, and it's all fine. And then you upgrade it with, say, a Docker build, you roll it out, and it breaks for one person, and the other is fine. And now you have a bloated Docker image, and then slowly your container is one size fits all. So how can it evolve further with it being this monolithic, right? So then a list of solutions come up, right? Let's break up this big Docker image into 3 different ones. Let's give people a DevOps image. Let's give people a security image. So let's ask partners, what kind of image you want? And then you have a data image, a security image. You try to meet in the middle, and a DevOps persona, a data persona, each with versioned variants. Now instead of 1, you'll have to maintain n times m versions, right? So a CVE, a vulnerability in curl, means you go patch everybody. And it's just, your ops has doubled, honestly. So if you look at these different versions, there's drifts between packages. So you have, you first have drift of the environment itself, and then you have overlap of packages. What if your container was never a right unit for the environment? I know it's excellent at process boundary, it's excellent at isolation, file system, namespace, network namespace. But somewhere, I think it evolved. Whoever's, maintaining the containers kind of made it, coupled it with package manager, package version manager, or a team shareable environment spec. It's been used for these purposes. And my argument is your substrate is not equal to environment. So substrate is the thing underneath that everything else depends on. So Kubernetes, for example, Kubernetes is a substrate for our workloads. You could say that. So the substrate is your OS, your libc, your base tools. You can have your container as your substrate. Let's define the container as the substrate. It should be owned by your ops team or your platform team. A Docker image is a great unit for the substrate. It's coarse-grained, it's stable, which is what you want. It is distributable. But then the environment, this is your tools, your startup scripts, your dependencies. It changes frequently. It should be owned by users. It needs to be fine-grained. It should be fast to swap. It should be independently versioned. And then we can tell people, just bring your environment into my substrate. We can manage our ops really well. Here, I think Nix closures are the right unit for the environment. And the key insight is they can be decoupled from the image entirely, injected at runtime, and not baked in at build time. That's a little hard, like injecting stuff at runtime. But then it frees the people who manage the substrate from breaking anything, and gives them the flexibility to upgrade, right, and maintain the substrate without fear, right? So so that's the argument. And also, in the whole DevOps lifecycle, you have an inner loop and an outer loop, right? And you have your package managers and your Docker build and your push to the registry, which is in the inner loop. And then I make a case where I can say Nix closures can give isolation in the outer loop without disturbing the integrity of the substrate. Okay, so before I get to this, I want to get to like a demo. Let's see. So in my demo, I do have, let's see, where is it? Wow. Okay, so I have, let me open my VS Code and show you a Docker Compose file, right? And I do have a volume mount that mounts a whole bunch of packages, Nix packages that I want. And from that volume mount, I just mount the binary cache into my workers. Yes? Oh. Okay, so thanks for letting me know. Now, let me just paste it and yeah. I'm just trying to increase the font size and put it in the terminal maybe. Right? Okay. Is this good? Let me just say Docker compose .yaml. Right? Yeah. Right. Thank you. So here it's just a volume mount with my Nix packages with your Nix channels, and I have a bunch of packages over here, and I do have a worker image which is just a basic image, and that's my substrate. And then I just have a demonstration as to how you can bring your environment inside the substrate. So Anyway, I think I need to increase the font size for everything. See. Is that readable? No? Okay. Okay. So I'm gonna start it from here. Let's just go here. I'm just. Okay. So I am just going to populate my Nix. Populate. Right, and it's populating all of my tools or Nix packages that I need. I kind of needed AKS MCP server and some other tools like Hubble and Helm and Claude. All of it is populated in the volume mount. And now I'm going to run my workers, right? Dash scale worker 3. So if you look at this, you have your substrate, which is basically it just has your NixOS. You can take any image, not necessarily NixOS. It's just your substrate. But then you brought in all your tools via the volume mount. So if I do a new window, and thankfully it's big, and then if it's a docker ps, right? And let's go inspect. Where is this name? Nix worker, yeah, 3. Any of these workers. And you will see it's got Claude, right? So I didn't go and install it. I didn't have to maintain it. I used a Nix closure that brought in these libraries inside my substrate. And it didn't really disturb the integrity of my substrate. So that's one of the things with Nix. But then there's a lot of, if I just look at, as I said before, I'm just a very new Nix practitioner, I would say. And I was trying to do switching Nix profiles, like removing the profile, like installing a profile, rolling back a profile. And you do need lots of familiarity with the CLI. And I think that's with a lot of learning and investment. You could do that, and that's my, I was just trying to see if there's a symlink that I can swap out, and it's all runtime closures, and so you can easily swap out versions. When you release new versions, you can update a store path, you can invalidate a store path, all of which can be done without going through your whole DevOps cycle and causing that whole timeline, right, for your team, and also ops for your team. So let's go to Flox now. Flox kind of simplifies this for me because it's also modeled a little bit like Git in the command line. So you're familiar with Git. So you see the Git init, Git pull, or, and you have Flox init, Flox pull. I think that was a smart thing to do because that's kind of instantly puts developers a little on the familiar ground. So I have a container, and thanks to the Flock folks for the last minute container stuff. So this, okay. So this is really small. So this is a container which has a Flox environment, which is the AKS MCP environment. So I created a Flox environment with AKS MCP server, of which I am the maintainer of. And I quickly went and checked once Kelsey said, did you write examples for AKS MCP server? I didn't. So yeah, so that's my AKS MCP server and Claude code, and I have them together, and I did not install them in my substrate, which is my Docker container. And the Docker container that I'm running right now is, let me show you that container size, right? It is the shell container, and it is about 13.5 gigs of just tools and packages. And with more AI tools and MCP servers and LLMs, the size is just gonna go up. It's not gonna be sustainable with this bloat. So this Flox, where it helps is brings your environment inside this substrate, where you can say Flox list, and I have my AKS MCP server and Claude code here. And if I exit, that's my substrate. I don't have it. And we can also use this to deliver fresher versions of packages, right? So if you go to user bin, which is a shared space for storing packages, right? We could make an argument and say, hey, I could just go plop like a bunch of packages through file mount under user bin. But that would destroy sometimes the integrity of the container because it's not isolated as a closure like how Nix is. So here's the Nix store that Flox used from where your AKS MCP, and I know this is not too readable, but that's the part that I think Flox abstracts. So yeah, so that's one of the things I wanted to show. And also I can take this environment, right? I'm activating the Flox environment over here. Okay, sorry, I don't know where that environment is. Let's see, it's probably in here, or it's probably in my home. There's a .flox folder. If not, that's fine. I can always pull my environment, and I can pull it. And so whenever you pull an environment, there's always like a rebuild that's triggered. And that's something, in a cloud environment, in a cloud infrastructure, that's a latency. That's like a runtime latency, right? So yeah, so that's something we gotta grapple with. So how do you do, like again, going back to this presentation, I think here, if you do not own your host, and if all your containers are gonna come up and die, then I think you need a sidecar that kind of puts your binary cache with the container. Like, so when you init, it's the whole sidecar inits with your binary cache along with your container. So all of the Nix binary packages are available on your sidecar, and your container is just able to activate environments from that sidecar. This is kind of expensive, and it's kind of an open question with ephemeral consoles, like consoles that come up and die, and we do this all the time in cloud, right? So yeah, so thanks for that. If you own the host, this is like a typical Kubernetes scenario where you own the node, then you can put your binary cache in the node, and then you could have the substrate and the pods pull from it. Yeah, so in closing, the environment is a closure and the container is a process boundary, and that's the case I'm making, where you have a minimal base image, stable, it's owned by ops, and you can rarely rebuild. And then you have personas as Flox environments or even Nix profiles. And then you can democratize it, and you can tell people, bring your own environment, bring your own manifest, and you could just load it up so that you don't have to carry all these things. Yeah, so I think I'm at time, and here's a couple of links. Thanks, everyone.